Good morning, everyone. My name is Tanya Kinnaid, and I am the sales manager for North America for the Artel portfolio here at Nova Biomedical. Today, we're going to be going over the Artel MVS, which stands for Multi-Channel Verification System. It's a great tool for verifying the performance of your liquid handlers and multi-channel pipettes. So I will get right into things. We're going to start with a set of slides, and then I will go into a hands-on demonstration. If at any time you have questions, please feel free to put them into the chat, and we will get those answered for you right away. Okay, so just a little bit about the Artel product portfolio. We have been providing data integrity, regulatory compliance, and workflow efficiency tools since 1982. We are recognized as the global leader in liquid handling quality assurance, and all of our products use a patented dual dye ratiometric photometry technology. That's really just a fancy way of saying that we use two different dyes to measure absorbance and then report a volume dispensed by every tip of the liquid handler or pipette that you're trying to analyze. And we'll talk a little bit more about the dual dye approach as we get into this slide deck. Let's see. So we have a pretty simple goal with the products and services that we offer, and that is to be able to measure volume consistently, regardless of location and device that you're using. So you can be assured that if you're trying to measure 2.5 microliters, as an example, that it will be exactly the same in Boston, Brussels, and Beijing, coming from your pipettes, multi-channel pipettes, or liquid handling instruments. And we accomplish that by a couple of different products. The Artel PCS in the upper left-hand corner of your screen, and then the Artel MVS in the upper right. For those of you who are not looking necessarily to invest in an instrument, we also offer a service called the Automated Liquid Handling Service, where one of our field applications people will bring the Artel MVS into your lab and measure the performance of liquid handling instruments. That's targeted specifically for automated devices. And then we also offer a series of training courses, one pipette technique certification and one pipette quality management certification. They differ a little bit in where we deliver those and the number of people that we deliver them to. But in any case, go over things like pipetting best practices and monitor and assess each one of the individual participants' pipetting technique. Going back to the hardware for a moment, the Artel PCS is sort of our flagship product. It was launched first and embodies that dual dye ratiometric photometry that I was speaking about in the earlier slide. It's designed for single channel pipettes and for verifying the performance of the people who actually operate those pipettes. We took all of that technology and then reformatted that into a microplate, which enables you to verify multi-channel pipettes and automated liquid handling instruments using the Artel MVS. And now we'll sort of zoom in a little bit on that product specifically. So some typical thoughts and concerns from our customers are things like, how do you select the right liquid handler for the job you're trying to do? Or how do you compare one robot to the next? Very often, you're going to have multiples of the same type of liquid handler, or maybe even different manufacturers within your lab, but they're all performing the same functions. And you need to ensure that those are performing exactly the same. Maybe you need to troubleshoot one of those liquid handlers or create a liquid class for one of them. In all cases, you're going to need a standardized volume measurement method in order to be able to make those types of assessments. And that's what the Artel MVS can provide. So in this slide, we have an image that shows you all of the different components of the Artel MVS. Of course, we have a plate reader that measures absorbance at those two key wavelengths, 520 and 730 nanometers. The system is sort of directed by the Artel software, which is installed on a computer, which is included in the package. We have a calibrator kit, a calibrator plate, which we'll also sort of talk a little bit more about in a moment, a barcode reader to pass all of the important information from each of the consumables into the software, our dye solutions, which contain those key wavelength dyes called QualiSure solutions. We have characterized verification plates. We'll talk a little bit more about those. And then we mix our two dyes together using the included plate shaker. On the left-hand side, we also include a label printer, and that really allows you to generate calibration labels and barcodes that will identify each one of the individual devices that you are trying to verify and link that to a calibration program within the software. So a little bit more about that technology, that dual dye ratiometric photometry technology that I was talking with you about earlier. We utilize a red dye solution as well as a blue dye solution in order to accomplish our measurements. The red dye will always be the sample or the quantitative piece of what you're trying to measure. The red dye comes in a series of different concentrations that allows us to span an a volume range that's able to be assessed between 10 nanoliters, and 350 microliters directly. Any volume over 350 microliters, we're still able to assess, but in a multi-dispense protocol. The diluent, or the blue dye solution, serves as our internal standard, and we backfill all of our wells to a total volume using that blue dye solution. Again, it's used to calculate the total volume in the well, and then we use the red dye as the sample to calculate the target volume that you're trying to assess. You can see in the equation down at the bottom that we're using the ratios of the known absorbances of those dyes that are pre-manufactured in our 17025 accredited laboratory, as well as the measured absorbances coming from the plate reader to calculate those volumes. All of that happens within 10 minutes, and you are receiving accuracy and precision information in one measurement. So there are a couple of different key parts of how we go about accomplishing these readings, and one of them is related to the verification plates. These look like off-the-shelf microplates, and essentially they are, but what we do on a lot-by-lot basis is characterize the taper angle of the sidewall as well as the bottom diameter of a statistically valid number of samples within a lot. That information goes into the barcode on the side of the plate. An additional correction that we do for these plates is a normalization. Injection molded plastic has inherent variability, and we normalize that variability by assessing the performance of each well in relation to its neighbor and ensure that all of that variability is corrected out. Again, all that information goes into the barcode and is scanned into the software during the reading process. Our solutions and our diluent are another key component of our instrument here. And as I mentioned, the red dye solutions, or the QualiSure solutions, contain that red dye, but they also contain the blue. And that's a really important piece because, as you can see, if you compare the absorbance spectrum on the left-hand side to the one on the right, the absorbance of the blue dye, or A sub B, is exactly the same in the QualiSure solutions as well as the diluent. That's really important because that makes our diluent addition a non-quantitative addition. It doesn't matter how much or how little you add, the absorbance will always be the same, and it allows it to serve as an internal standard. The red dye solutions, the core product line is aqueous in nature. However, we also make these dye solutions in different matrix that will allow you to mimic how the liquid handler would perform when dispensing the solutions that you use every day. So for instance, if you dispense solutions that are in 100% DMSO, we have a series of dyes for that. If you dispense something that pipette, like PCR Master Mix, we have a dye that pipettes in the same way that PCR Master Mix does. It contains a surfactant component as well as a viscosity component. And then we have two others called Serum Sub and Plas Proxy. Those pipette as you would expect, like serum and like plasma. All of these dyes are stable and traceable to NIST. As I was mentioning, there are 5 different QualiSure solutions that allow you to mimic the liquid type that you would dispense, and these are those that I just mentioned. Another key component to this is our calibrator plate, and this is sort of the heart of our system. This is what ties the performance of the plate reader back to a NIST traceable spectrophotometer here in our reference lab. When that plate is manufactured, it is measured on that NIST traceable spectrophotometer here at the lab. All the information on how those cuvettes that the plate contains is encoded on the barcode. And then when you read that plate on the plate reader on the day that you're using the Artel MVS, it takes the performance or the absorbance measurements of those cuvettes that are measured on the plate reader and compares them to how they were read on the reference spectrophotometer and creates a correction. The function of that really is to make sure that every Artel MVS performs exactly the same as our reference. That extends the traceability from our reference spectrophotometer to the results coming from the plate reader. That means if you have 5 Artel MVS systems in 5 different locations, they'll all perform exactly the same. So just a little bit on the workflow before we get into the hands-on piece of this. You will dispense the red dye solution from your liquid handler or pipette that you're trying to test, and then you'll backfill with a blue diluent solution. I mentioned before that the blue diluent addition is non-quantitative, so it can come from the liquid handler that you're trying to assess, but it can also come from another liquid handler or a bulk dispenser, something that will get that blue dye solution into the plate. Again, non-quantitative, so it doesn't matter how accurate or precise that dispense is, as long as you're within about 20%. These steps can also be interchanged. So we would like for you to use the MVS to mimic what you normally do every day. So if your key solutions that you're trying to dispense are dispensed into a dry plate, we'd have you put the red dye in first. If they're normally dispensed into a plate that already contains solution, we'd have you put the blue dye in first. Again, just trying to be as close to what you normally do every day. Once the 2 dyes are together in the plate, where they're mixed together using the MVS plate shaker, and then read on the plate reader. We take those readings at 730 nanometers and 520 nanometers and use the calculations to determine a volume on a well-by-well basis. That allows you to analyze each tip of the liquid handler individually and get accuracy and precision information for each. So this slide just really goes through all of the different compliance features of the Artelware software as well as the system itself. It is a method that's mentioned in the ISO 23783 standard for liquid handlers. It's also mentioned, the technology is also mentioned in the 8655 standard, and the software can be used in laboratories that are compliant to 21 CFR Part 11 with electronic signatures and a full audit trail. A little bit about the software, and we're going to go into this in a little more detail when we get to the hands-on piece. The home screen has a nice dashboard feature, which really walks you through every step that you need to get started with the Artel MVS. It will walk you through how to add all of your liquid handlers to the database, create test plans, and then walk you through the process of actually assessing them. The home screen is customizable, and you can also view the devices that are due in specific locations or belong to specific owners. The software does have comprehensive reporting. The reports are customizable. You can put your own logo on them. You can add an accreditation logo if you have one. As I mentioned before, there's customizable barcode and calibration label printing. The image on the left side bottom of the screen shows the barcode that can identify each individual device you're assessing, and then the one at the bottom shows the calibration label that can be generated once the liquid handler passes the test plan that you've defined. On the right-hand side, we have an example of a report. In this case, it's an 8-channel pipette or liquid handler, and you can see that each individual channel is assessed independently, and pass or fail is judged for each. So while I wrap up the slide portion of this, you may ask, why would I do this instead of something else as far as a volume measurement technology? And we recognize that there are lots of other options out there. However, as you're trying to assess which one is right for you, please consider that there are lots of sources of variability that come into a volume measurement, coming from things like the liquid handler, the reagents you're using, the tips, the temperature in your environment, the operator if you're trying to assess pipettes, as well as mixing, the detector itself, and the plate type. And what the Artel MVS does is minimize variability or remove variability from all of the sources except from the liquid handler and the tip combination itself. And that's really what you're trying to assess. So I'm going to stop there as far as slides go, and I'm going to switch my cameras over. If you have questions at this point, please go ahead and ask them. All right, now can everybody still see my screen and now see the home screen of the software?
Yes, and it looks like Maria may have a question as well. Maria, yes. I think you're muted for the meeting, but if you throw it in the chat, I could read it out to Tanya as well. Or unless you're raising your hand if saying you could see the MVS and or Artel screen. I don't know which one.
Perfect. Thanks, everyone.
It looks like Maria's question is, different solutions are provided depending on the type of liquid being tested. For example, aqueous, DMSO, PCR mix, serum sub, plasma proxy, etc. And the dilution setup appears to vary depending on the target volume range. Is that correct?
Yes, that is correct. So there are a series of different concentrations that allows us to sort of counteract the limitations on the dynamic range of absorbance. So for example, if you are trying to measure a volume that is high, maybe around 250 or 300 microliters, you'll use a more dilute solution. When you're trying to measure a volume that is low, let's say 10 microliters, even 10 nanoliters, you're going to use more concentrated solutions. So there are a series of different concentrations. The software will tell you which is appropriate for what target volume you have. And that will bring us within a measurable range for the plate reader. Does that answer your question, Maria? Okay, I'm going to assume it does. If it doesn't, please ask another question in the chat.
Yes, it does.
Okay, perfect. All right, so we are going to walk through a couple of steps. Some of them are setup steps that you will only perform once, and some of them will be what you do every day, and I will indicate which are which. So you can see up here at the top, we have our Get Started bar. You are able to add specific users and use Windows authentication to enable or disable specific capabilities for different users. You are able to add locations. So if you have several labs with devices in each lab, you can sort of sort them out using the different location capability. I'm going to skip over Add Instrument, but I will say that this is the software that runs both our MVS and our PCS. So if you did have the need for verifying both single channel pipettes and multi-channel pipettes, you're able to connect both instruments to the same software. In the fifth step, that's where we're going to be adding our devices. So this is where you create a catalog, essentially, for all of the devices that you're going to try to measure. And we'll walk through that. You can also create your test plans from here, and that's going to be what volumes you'd like to assess and where you would like to dispense those within the plate. And then you can put each of your devices on a schedule. So if you would like to get reminders from the software via email, you are able to do that when pipettes are due, or if you would like to enable this feature, you can have a reviewer of the results that's different than the person actually collecting the data. Down here at the bottom, we've got shortcuts that allow you to scan barcodes, quick launch, calibrating pipettes and liquid handlers. The software will also walk you through how to use our products to train pipette operators, and then you can force calibrations of the actual instrument right from here as well. So I'm going to start by adding a device today. You can see that we've got both options, as I mentioned, for pipettes and liquid handlers, and I'm going to pick liquid handler today. And then we get to the part where you define which device you're actually trying to measure. So under the details tab, if you click on the ellipsis, you will find just about every type of liquid handler that's on the market. And they are sorted, of course, by alphabet. And today I'll just stick with the first one because it's easy. We'll pick an Agilent liquid handler, and let's call it a Bravo. You can also add any type of model if you don't see it in the drop-down menu by clicking the plus button. Then you can add your own specific liquid handler ID if you call your liquid handlers Star Wars characters or Simpsons characters. You can call it whatever you want. I will call it test 1, 2, 3 for today. You can also add descriptions and serial numbers. You will identify the location of where your liquid handler is sitting and the owner. In this case, I am going to select April showers. Under dispense heads, this is where you're going to define the different tip combinations that you have attached to this liquid handler. So for instance, I know some have 8-channel liquid 8-channel heads with 96 channel heads. Some have 3D4. You're able to add all of those to a specific platform. So you can add multiple heads to the same platform by clicking the plus button and then adding a dispense head. So you can call this, again, whatever you would like, and select the number of channels. You can select anywhere between 1 and 384. When you're finished adding dispense heads to this platform, you click OK to add this to the list and then click Save to commit it to the database. Now we have our new device, test 1, 2, 3, which is an Agilent Bravo, added to the list. If we go back to home at this point, we'll define what our test plan looks like by clicking Create Plan and defining a liquid handler verification. So it's definitely possible that you'll have more than one plan for any liquid handling platform or pipette. So today, what I would like to do is test 100 microliters and 200 microliters in the same plate. You can pick either 96 or 384 well plates. I'll stick with 96 for today. You'll remember I defined an 8-channel head, so I will leave this here. However, in the drop-down menu, you'll notice that we have all of the same device combinations that we can pick as when we were setting up the device itself. The orientation and tip spacing, you will pick what is appropriate. In this case, because we have an 8-channel device, it is the options are fairly limited. However, these will change with the number of channels that you select. Then under liquid class name, you can define what that is, and then you will select your evaluation criteria. These come as default checked for inaccuracy and precision to include the channel statistics as well as the dispense order statistics. And let me explain that a little bit. Channel statistics will evaluate the performance of the liquid handler on a per channel basis. In the dispense order situation, what it is going to do is report on how the pipette or liquid handler performed in the first dispense versus the subsequent dispenses. So we'll go through that in the report, but I'm going to leave these checked. And then you can also decide to report your values as absolute volumes instead of percent. If we click on the dispense steps, this is where we're going to start adding the information about what we're dispensing and where we're putting it. So you'll remember I said I wanted to dispense 100 microliters and 200 microliters into the same plate. So 6 replicates of each. I'll start by putting the 100 microliters as my dispense volume. I will pick the solution type. Again, you'll remember that I said the core product is aqueous, but there are several other types of solutions that you can pick. If none of those solutions that I mentioned actually mimics what you normally dispense with your liquid handlers, you can also create your own custom solution by spiking our concentrated dye solutions into a different type of solvent. And we do have some information on how that works that we can provide to you after the demonstration if you're interested. And that's what custom is referring to. I'm going to stick with aqueous for simplicity today. And then I will define the number of replicates per channel. Remember, I said I'd like to do half a plate of each volume, so I'll select 6. You are going to then determine what your inaccuracy and imprecision pass or fail limits are. Today I'll put 3 for 100 microliters, but just know that you can also define different inaccuracy and imprecision tolerances for each volume that you're dispensing. Then you'll just select a color and click on the dispense step. I'm going to dispense half of the plate as 100 microliters. Now you can see that I have highlighted that plate and it shows the first dispense versus second and third and so on. Now I'd like to add that second volume, which is the 200 microliter volume. So I'll go back here and click the plus button, do the same steps over again, only changing the dispense volume and the same number of replicates. Let's put 5% for the pass or fail tolerances here. And then I'll just pick a different color to indicate that this is a different volume in the plate. So now I've defined exactly what it is I'll be dispensing and where I'll be putting it in the plate. This is a one-time step. Once you define these verification plans, you don't have to do it again. You'll just be selecting from the library. When I click approve, it will ask me to put a comment in if I need to. And now I have my new test plan called 100 and 200 microliters in my list. Those are the 2 setup steps that are required. After that, you're ready to go. So I'll go back to the home screen. I will say that I want to verify a liquid handler. You can either do this in a scheduled fashion or an ad hoc fashion. And then I need to select exactly what I'm going to be testing today. So I've got a library of different things that are listed here. I defined the Agilent liquid handler earlier, so I'm going to select that. And then it's only going to show me the test plans that are appropriate for this type of liquid handler. You remember mine was called 100, 200, so I will select that. And then start verification. And now the software is really just going to walk me through all of the steps that are appropriate for testing this liquid handler at 100 and 200 microliters. So you can see that it wants me to scan some of the barcodes on the solution. So you'll remember earlier I said there are different concentrations of the dye solution. It's asking me to use range A for this test that I'm doing. This is one of our more dilute solutions, so I will scan that as requested. Then it's asking me to scan the diluent solution. Again, this is that blue dye that we're going to use to backfill the volumes. And then it will ask me to scan the plate that I'm using. And now it's going to tell me exactly what I need to do. So you can see on the left-hand side of the screen, it's asking for 6 replicates of 100 microliters as we defined, and then 100 microliters of diluent in each one of those wells. And then in the red wells, we're going to do 200 microliters of the red dye solution, and anything 200 microliters and over, you actually don't need to add the blue dye to the wells. Now you guys can just judge my pipetting skills. And actually, when I get to a specific point, I am going to, on purpose, dispense the wrong amount so that we can keep track of that one well and see how it reports. Please feel free to put your questions into the chat. All right, so I am going to dial this pipette up to 200 for that second half of the plate. And just so everybody knows, the blue dye solution that I was required to dispense in that first half of the plate I put in before the demo, just to save us a little bit of time. So now you can actually see that I do have a bubble in here, so we probably should see a bit of a different performance on that one. But in well H11, I'm going to remove some of that solution. See how that tracks when we do our measurements. All right, so now I have my solutions in the wells as it dictates on the test plan. We're going to start the shaking. The function really of the shaking piece of this is to make sure our blue and our red dye solutions are completely homogeneous. You can imagine if we had, concentrated pockets of dye and then we try to measure absorbance, we're going to get some pretty crazy results. So what we want to do here is just make sure that those dyes are fully mixed. For a 96 well plate, this process of mixing takes about 1 minute. For a 3D4 well plate, it takes about 2.5 minutes. Those wells are just a little bit harder to make sure that we get full mixing in there. But one of the other really great things about the Artel system is that you're also able to determine how well your liquid handler is mixing. If you have a mixing step within your dispense protocols on your liquid handlers. And again, we have an application note that really describes exactly how you can do that. Happy to provide it after the demonstration. So once the mixing is complete, we're going to move the plate from the shaker onto the plate reader and collect those absorbance measurements. So now the plate reader is going to go about its business, collecting absorbance readings at the 520 nanometer wavelength first, and then followed by 730 nanometer wavelength. This is a single channel plate reader, so it is not measuring multiple wells at the same time. It's measuring each one individually. And while that does sometimes take a little longer in relation to a multi-channel plate reader, it also allows us to really control any variability that's coming from the measurements itself. We don't have to worry about several different light sources, several different detectors. We're able to really hone in on really great performance from the one channel. So the process for a 96 well plate of reading takes a little over a minute. For 3D4 well plates, it takes about 1.5 minutes. So all told, for measuring a 96 well plate, it takes about 2 minutes. For 3D4 well plates, it takes about 3.5. So now we have our results that are ready to be computed. And you can add comments through the software at that point as well. Now we can take a look at the report. So this is what you're getting for an output. You can see that I've got my liquid handler name here, what it is, the type of head that it is, the dates and times, sort of all of the vital information up here at the top. If we scroll down into the report a little bit, now we can see that we've got that target volume of 100 microliters. We did 6 replicates, as you'll remember. And here is our average information for that 100 microliter volume only. We're going to get a mean, standard deviation, inaccuracy, and imprecision, and then it's going to compare that to the tolerances that we set. In this case, we got passing results for the 100 microliter test on average. And then if we take a look at the channel statistics, now it's going to evaluate that liquid handler on a per channel basis. So it was an 8-channel liquid handler, 8 different statistic sets. And again, you'll get the mean, standard deviation, inaccuracy, and imprecision, as well as a pass-fail result for each channel. Going back to that dispense order that I mentioned earlier, we did 6 different replicates, so there are 6 different set of statistics here. And what this really enables us to do is see whether or not that liquid handler is tracking or trending in a specific direction as it dispenses across the plate. You can see I didn't really pre-wet my pipette tips, and I got a smaller volume in that first dispense than I got for the rest. And that's something that we would expect when you're using a pipette. So then we have pass or fail results here as well. And now we've got a bird's eye view also of that part of the plate and each individual volume that was reported. Now you can imagine if you compare this set of results to what you would get if you were trying to just weigh a plate and then get results that way, you'd end up with the average, but you certainly would not end up with the individual assessment of each one of the wells. So now let's take a look at that 200 microliters. You'll remember the well that I told you that I took some solution out of. So we're going to take a look at that specifically. You can see that it very much does show up in our results as a negative 5.3% for inaccuracy, and that really makes my imprecision jump up to 14.33% as well, and it is marked as a failed test. You can see that again in the dispense order. You'll remember that I took some out of that one individual well, so it affects the 5th dispense that I did. And then if we take a look at the bird's eye view, here's that well that I took the sample out of. Down here at the bottom of the report, we've got lot and serial number and expiration information related to the solutions that you're using, and you are able to apply electronic signatures to these and export the reports either in PDF format, Excel, or Word. If we go all the way back up here to the top, I wanted to just also show you one more feature of the software, and that is the heat map. So this is a min-max heat map. It applies color gradient to the results. It doesn't change any of the numbers in my report. However, it does now apply that color gradient I mentioned. Everything that is highest in the well is going to be colored red. Everything lowest in the plate is going to be colored blue, and then it will apply that gradient in between. Now, please keep in mind, I said this is min and max, so it doesn't matter what the deviation is in between the min and max, it's still going to apply that color gradient. If we take a look at that well that was very specifically off, you can see that it really does skew that color gradient as well. And then overall, because I did have that one well that was kind of funky, I did end up with an overall failed result for this report. Okay, so I'm going to stop there. I'll switch my camera back to me and ask if anybody has any further questions that I can answer. Okay, if nobody has any additional questions that you've typed into the chat, Always feel free to reach out to us separately after the demonstration is done. We'd be happy to provide you with a recording, as well as the additional information that I mentioned during the demonstration today. If you do have further questions that you wish you'd ask afterward, again, please feel free to reach out. Thanks so much for your time, and I hope you all have a great day.